Hello everyone. My name is Susanne Schmidt from the University of Hamburg, and I'm very happy to be here today and to show you the results of one of our latest research projects. And actually this project is part of a bigger idea to build what we call a blended space. So first I would like to show you what we mean with this concept of a blended space. So a blended space is an environment with physical, real objects that can be transformed into any state within the reality-virtuality continuum. So for example, a natural history museum could just take one of their exhibition rooms and could place an exhibit, a real exhibit inside of this space, and could then augment it. So for example, to say just augmenting small parts of the exhibit, like only highlighting some body parts, or showing the entire skin virtually, so how did the dinosaur look like, or even they could show in this space how was the context of the dinosaur. So all of this could be done in the same space, in the same spatial boundaries. And the second special feature of a blended space is that all of these states, or the transitions between all of these states, have to be seamless. So a user does not have to put off his Vive and then use a HoloLens if he wants to transition from a VR condition to an AR condition, for example. And the first challenge we were faced with was which kind of technology could we use to build such a blended space, because most of the existing AR hardware is very limited in terms of the field of view. So we could not use a HoloLens, for example, to build an immersive virtual environment. So we decided to use a technology which is called Spatial Augmented Reality, or projection-based AR, or projection mapping, which means that you can mix virtual content and real objects without additional displays. So all of the content is projected directly onto the surfaces of the real objects. And therefore the user does not have to wear big glasses or a tablet in his hands, so it's very comfortable for the user. And since we want to augment not only the object but also the environment or the surrounding, we need more than one projector, and we built some kind of extended cave. So we had 3 walls and 1 floor as projection surfaces, and in addition we had 1 projector for the physical object inside this cave. In this case it was an exhibit, this dinosaur I showed you some slides before. And within this cave we wanted to show different kinds of virtual content, so both monoscopic content, stereoscopic content, and also view-dependent content which was floating inside of the cave. So we also had to install a tracking system, and one of the users was tracked, or his head position was tracked, and the view-dependent content was adapted to his current position, so the perspective was correct for this user. And inside this extended cave, the example I showed you before looked like this. So this is one of the states within this continuum, with the highlighted body parts or with an entire virtual skin, so the user could move around this physical skeleton which was augmented with the skin, or he could see the environment the dinosaur was living in. And this technology, Spatial Augmented Reality, had some benefits for us, or for our idea of building such a blended space, because we can present reality, virtual reality, and all states in between. We also have a large field of view when the user is standing inside this cave-like environment, and we have a minimum level of user instrumentation. So if we want to show monoscopic content only, then the user does not have to wear glasses at all. And if we want to show stereoscopic content, then lightweight glasses, like in 3D cinema, are sufficient. So this is a benefit in comparison to other AR solutions. Also, in this blended space with Spatial Augmented Reality, we have some kind of shared space, both virtually and also in reality. So multiple users can see the same content, the physical content and the virtual content. And we found in previous experiments or demos that this is very preferable. So most people like this very well. And I think also in the keynote session we saw that it's very important for public installations to have this social idea of such installations. On the other hand, we also have some disadvantages, or maybe more challenges, using the spatial augmented reality for this kind of application. First, we need a way to do the transitions between all these states. So usually if you have a head-mounted display, you also have specific controllers, or for HoloLens you have the predefined gestures. But for spatial augmented reality there are no integrated devices, all people know, so they would have to learn them, and we didn't want them to learn new gestures or new input devices. So we thought about how could we solve this without this new input devices which have to be learned. Another challenge, which is very special for projector systems, is the self-shadowing. So objects cast shadows in such systems, and sometimes even on their own object parts. We cannot solve this, but we can try to guide users to favorable places. So if they are very close to a projector, then the self-shadows are reduced, and this is what we wanted to try. And last but not least, although it's a shared space, we have the problem that if we want to show the view-dependent content, for example, this virtual skin which is floating inside the cave, then it's only a single user system, because only one user can see it with the correct perspective, and for other users it's distorted, unless they are also moving to the same spot as the tracked user is. And this is what we wanted to do with our user interface. So we wanted to improve user interaction, user guidance, and also user collaboration within such a blended space. Because of this, we developed a user interface, and we decided to project it onto the floor because we thought it's very intuitive, easy to learn. It's not very distractive, so users can still focus on the exhibit which is in front of them. And of course, we also evaluated it. I will show you this in a second. And for this floor user interface, we designed different user interface elements. The basic element are some buttons with footsteps, so the user knows that he has to enter such a button if he wants to interact with the system. And with these buttons we were also able to integrate some kind of meaning with regard to the position and the orientation in the cave. So for example, if we want to show a scene where the user has to observe the object from a very near distance, then we can also put the button very close to the exhibit. But if he wants to get an overview, for example, for this context scene, then it makes more sense to place the button further away. When one user entered a button, a progress bar appeared, and afterwards a 2D floor map expanded. And this floor map was like a safe walking space or walking area. So when the user was walking inside this area, we could make sure that he get good viewpoints. So the self-shadowing was reduced, or was to a minimum within this walking area. And also from a narrative point of view, we could make sure that he's always seeing the exhibit from the points which are most interesting for this specific scene. And also we integrated a region of interest segment, which you can see on the bottom part, which only directed the users to parts within the scene where the action takes place in the specific scene. And for collaboration, we introduced a master-follower concept. So the first user who entered a button was the master, and all of the view-dependent contents were adapted to his current position. And all other users are the followers, and they get a circle around them. And when the circle is red, this means that they have a very bad viewpoint for the current scene, so they are directed to the master user, and if they are close to the user, the circle turns greenish. So these are the different elements we used, And we tested them in a user study with 40 participants of different ages, between 19 and 65, and we had most participants from our own department, but also participants with a non-technical background. And since we wanted to test the collaboration, we decided to use pairs of participants. So in every experiment session, 2 users were using the system together. And we also decided to balance partners or groups where the users knew each other before the experiment or they didn't know each other before the experiment, because we thought for museums this is very common, that sometimes you are visiting a museum with your friends or with your family, but it might also be that you are in front of an exhibit and you are meeting a stranger, and we wanted to make sure that our interface works for both groups and not only for people who know each other. So we simulated the exhibition scenario, as I showed you before, with the dinosaur skeleton, and we compared our extended user interface with a basic one, which only featured buttons which were pulsating to make sure that the users know that they can enter these buttons. And we compared these 2 conditions with a between-subject design. We collected different subjective and objective measures, but I only will show a subset of them. So you can see the basic UI represented by the green bars, and the blue bars represent the extended UI. And we had some questionnaires regarding usability and also feedback quality. And as you can see here, the extended UI performed significantly better for feedback usefulness and also feedback accuracy in comparison to the basic UI. And we also investigated collaboration with some objective measures. So for example, for the scene with the virtual skin, it's very important that both users are close together. So both users, the master and the follower user, get a good viewpoint. So we wanted to reduce the head distance between the 2 users. As you can see here, for the extended UI, the head distance was lower in general, but what is even more interesting is that for unfamiliar users, it keeps nearly the same as for familiar users. In comparison, for the basic UI, users kept a much larger distance when they are not familiar with each other. And in the right diagram, you can see a balancing score. So in our implementation, we didn't do some balancing. We thought it would be best if we had a first come, first served principle. So the first user who entered a button was the master. If he left the walking area, then the assignment of the roles started again. So the users had to do the assignment of the roles by themselves. And as you can see here, for the extended UI, this worked very good. So a balancing factor of 1 would be best, and in this case it's very close to 1. For the basic UI, it didn't work so well. So in some groups, one partner was the master all the time and the other one was the follower always. So the interface elements help the users to understand that they have to balance this somehow to get the best experience for all of the users. We also investigated communication behavior, so if you're interested in that, please have a look in the paper. And in summary, we implemented and evaluated a user interface for these kind of blended spaces with a floor projected elements. And the evaluation was done with a user study with 20 pairs of participants, and the results indicated that the interface is self-explanatory, that it's easy to use, that it encourages users to move closer together. But we couldn't find any positive effects on the storytelling, so we also asked users, did you understand the story? Was it easy to follow? And we got high scores both for the basic and the extended UI. So for future work, we could test this in a more complex scene because our scenes were very simple. And also what we didn't test was learning success. So this was not the focus of this study, but it would be interesting if users were distracted by the user interface, and therefore maybe the learning was worse than without. But we hope at least that they are more excited and more interested, and therefore they learn more than without the interface. So that's all. Thank you a lot for your attention. And if you have questions, don't hesitate to ask.
Any question? Yes, please.
Mohammed, Zarland University. I have a multi-part question. So how did you, maybe you mentioned it, but how did you measure the head distance? And secondly, what is the effect of the head distance on, for example, the storytelling or actual experience overall of the two users? Because if you get too close, I guess it's kind of inconvenient, right? Thank you.
Yeah, that's a very good question. So we had some markers on the stereo glasses or shutter glasses the users had to use. And the head distance was just a distance between the center of these markers. And this is also was an observation we did, that sometimes if they were too close together, of course for the unfamiliar users it was somehow strange. So for some scenes it was not important that they are too close. It was only important that they were not too far away from each other. But for this virtual skin, if they are only 1 meter away from each other, then one of the two users would see the skin floating besides the skeleton and not around the skeleton. So for this particular scene, it was very important for the experience that they are close together. But I think for future projects, we also have to think about how can we prepare the scenes that they are best for such experiences. So I think for the skeleton in particular, it was a little bit difficult to get a good experience for both users. But what we also saw is that with the extended UI, the users realized that the master user was the one who had the best view, and so they left the scene and said, now you can test it also. So it was still a very social experience. So still it helped, I think.
Hi, George, University of British Columbia. I was wondering, when your users are wearing shutter glasses, couldn't you just render different viewpoints in alternate frames so each user can get their own viewpoint with maybe a lesser frame rate?
Yeah, I think there's a very popular paper from Weimar. So they have these projector systems which can be used for up to 6 users by using this shutter system. So this is also mentioned in the paper as a possibility to show it for each user, so a different perspective for each user. But first, it's kind of expensive and difficult to use. So we also work with museums, and if we can tell them you can use one projector, off-the-shelf projector, then they say, okay, we can do this. But if we would tell them, yeah, you need a very complex, expensive hardware setup, then they probably would say this is not possible. And also what I always think is then you again have these private views for each user. So it's very similar to a HoloLens, for example. And what I like about this system is that even if you have a distorted image, you know what the other person is seeing. So actually, for me, it's more social than these private views, but I understand that it's maybe a better experience if each user has the perspectively correct image. So I think, yeah. Yeah, that's
covered because they just glass shutter.
Mm-hmm.
They all see the same. They can even point at the very same point in space or so. I tried it out, so everybody sees what the others see as well. So you don't have specific. I mean, you could do that.
Yeah, this is the problem. Yeah.
But typically, you are able to share the same space.
Yeah. So actually, I didn't test it, but for me, I thought maybe you are not sure that the other person is seeing the same as you do, but yeah, of course. Thank you.
Okay, thank you.
Thank you.